All right, section 1.5, we're going to talk about radicals and rational exponents. Now, radicals are things like square roots, cube roots, fourth roots, things like the square root of 49, that's a radical. Rational, the word rational means fraction. So we're going to look at the relationship between radicals and fractional exponents. Now, all the rules that we talked about in the last section are going to apply to fractional exponents as well. So let me just remind you that the square root of 49 is 7, and I want to ask you why that is. Well, it's because when we look at the square root of 49, we're looking for a number that when you multiply it with itself will get you to 49, and that number is 7. 7 times 7, which is 7 squared, that's 49. All right, square roots undo squares. That's what we need to understand about square roots. Cube roots undo cubes. We're going to talk about that in a second. Let's do one more square root problem. Square root of 81, that's going to equal 9 because 9 times 9 is 81. 9 squared is 81. So when we write down the square root of 81 equals 9, that's another way of saying that 9 squared equals 81. They say the same thing a little differently. So over here, let's talk about cube roots for a second. A cube root, well, let's remember what it means to cube a number. To cube a number means to raise it to the third power. So for example, 2 to the third power, 2 times 2 times 2 is 8. So 2 cubed is 8. We undo a cube by doing a cube root. So to undo cubing, we do a cube root. And the symbol for that is, it looks a lot like the square root symbol, but it's got the extra little 3, and we call that the index of the radical. So the cube root of 8 equaling 2 is another way of saying that 2 to the third, or 2 cubed, is 8. So the cube root undoes the cube. Okay, now I have switched to the next page. We're going to talk about nth roots. We're going to extend the idea of square root and cube root to just fourth roots, fifth roots, sixth roots. We call them nth roots. So in general, for an integer n greater than 1, so like 2 or 3 or 4 or 5 or so forth, if b to the n equals a, we call b an nth root of a. So for example, because 2 to the 5th power equals 32, 2 is a fifth root of 32. The notation that we use for the nth root is right here. We read that the nth root of a. This expression is called a radical, and the number n, whether it's 2, 3, 4, 5, 6, whatever it is called the index of the radical. Now, one thing I do want you to make sure we understand, we're going to look at the square root of 5 here for a second. Square root of 5 is the number that when I multiply it by itself will get me to 5. But when we multiply something by itself, we are also squaring it. Right? So the square root of 5, when we square it, is going to get us to a 5. So the square root and the square undo each other. But I want you also to think about how multiplication works. If I wrote that square root as a 1/2 power and used the power to a power rule, those exponents would multiply, and I have 5 to the first power, which is 5. So what we're going to need to understand from this section is that a square root is the same as a 1/2 power. A cube root is the same as a 1/3 power right here. Square root is a 1/2 power, cube root is a 1/3 power, fourth root is a 1/4 power, and so forth. Nth root is a power of 1 over n. That's probably the most important idea from this section. All right. Another thing we need to understand is that when we talk about a nth root of a number a, there might be more than one. The square root represents just the positive, but if I just said find solutions to that equation, there would be two of them. There would be a 4 and a negative 4. So we say that 16 has two square roots, a positive one and a negative one. And that's this idea right here. So if n is odd, there's only one real nth root. But if n is even, there will be two nth roots. There will be a positive and there will be a negative. If n is even, any nth root of 0 is 0. And if n is even, and what we're looking at is, let's say, something like the fourth root of, let's just do a square root. Let's keep it small. Square root is something like -2 or -4 or whatever. That is not a real number. We'll talk about imaginary numbers in chapter 4. So that's coming up. All right. Let's do a couple examples. So we're going to look at example 1. We're going to find the indicated real nth root of, or roots of a. So in part A, we're looking for a number that when I raise it to the third power creates -27. And there's only one of those. It's going to be -3. We're looking for the cube root of -27. There's only one. It's -3. All right. Now with part B, we're looking for the fourth root. The index there, n equals 4. So we're looking for the fourth root of 16. But I want the positive and the negative. That's why it said find the indicated nth roots of a. There will be a positive one and a negative one. And that's going to be positive and -2, because 2 to the fourth power equals 16, but so does -2 to the fourth power.